Okay, so now we're gonna write a function that's an extension of the integer, and we're gonna see if an integer is prime. What is a prime number? Does anybody remember what a prime number is? I'll tell you what a prime number is. Prime number is any number that cannot be divided by or divisible evenly by another number that isn't one, right? So of course, you know, um, one is a prime number, right? But is two a prime number? Yeah. Sure. Two's a prime number, right? What about three is a prime number? No, right? Because there's nothing that divides into three evenly, right? 11 a prime number, nothing divides into 11 evenly. 13 is a prime number, no, nothing divides into 13 evenly, right? 17 is a prime number. 23 is a prime number, right? Um 31 is a prime number. So, okay. So let's go ahead and let's calculate, right? Um Extension, integer, right? Func is prime, right? Return Boolean, right? So we know that if it's less than two, it's prime, right? So less than equal to is prime, right? Guard. I use a guard statement, right? So less than equal to two. Sorry about that. Okay, so it's true if that's less than equal to, right? And so for um, to anywhere to self, right? And then we're gonna make another guard statement in this because if all we have to do is meet our conditions one time and we know it's false, right? So guard self modulus I, right? And if it's not equal to zero, that means that's what the modulus does. Modulus says once we divide by I, what's left over? If it's not equal to zero, guess what? We don't have the conditions we want. We're going to return false. Right? And then otherwise, guess what? We're going to return true. That's really it. So now let's go ahead and let's see. 3 dot is prime. Three is prime. Is 4 prime? No, it isn't. Is 6 prime? It shouldn't be. No. But guess what? 13 should be prime, right? Right. 17 should be prime. 31, 23 should be prime. And 31 should be prime. Okay. Yeah. And so that is, yeah, on to the next.